Hello, everyone, and thank you for joining my session at Conf42 DevOps 2026. My name is Saideepak Kandibanda. I work at Dish Network LLC and the Senior Engineering Manager leading AI engineers and automation engineers, where I focus on bridging AI systems with secure and compliant DevOps practices. Today, I will be sharing a framework I call the AI Trust Triad, a practical approach to deploying reinforcement learning, federated learning, and explainable AI safely in regulated production environments. The goal is simple to help DevOps team ship AI systems with the same level of confidence, traceability, and control that we expect from any critical software system, but down, without slowing down innovation. Okay, and get started. The real challenge isn't in deployment. Let's start with what's really changed. A few years ago, deploying AI was the big challenge. Now, deployment pipelines have matured. We have Kubernetes, CI/CD, infrastructure as code, and they work beautifully. The real challenge now isn't about getting models into production. It's about operating them safely once they are there. AI is moved from experimental research projects to powering financial, supply chain, and customer facing systems that directly impact compliance, risk, and trust. So, the new frontier for DevOps is about safe operations at scale, ensuring privacy by design, maintaining auditability, and having the ability to roll back instantly if models drift or misbehave. Next slide. Now I'm introducing the AI trust trade. To tackle these challenges, I introduce what I call the AI trust trade. Three complementary pillars for trustworthy AI operations are reinforcement learning, federated learning, explainable AI. So I will get into in detail about these three. On a high level, what is reinforcement learning? Which enables adaptive decision making that evolves with the environment but must stay within defined control boundaries. What is federated learning? Which allows organizations to collaborate on model training without sharing sensitive data. Explainable AI, which ensures transparency, accountability, and confidence in every decision made. These three approaches together form the backbone for responsible, scalable AI in DevOps pipelines. Let's get into deeper into each category. Let's start with reinforcement learning through a DevOps lens. Let's start with reinforcement learning, RL in simple words. In a DevOps context, RL isn't just a research tool, it's becoming a way to continuously optimize operations. For example, in portfolio optimization, RL dynamically reallocates assets while respecting risk and compliance constraints. In risk management, we can have automated circuit breakers that react to volatility in real time. And in supply chains, RL can optimize inventory and routing based on live demand and disruption signals. The key is building guardrails into RL pipeline so the system learns safely without creating intended consequences. So we cover three examples: portfolio optimization, risk management, supply chain. Let's get into operational requirements for RL systems. From an operational standpoint, RL requires a completely different level of governance compared to static models. What are those? Policy versioning, safe exploration, reward monitoring, meta risk detection. What is policy versioning? Every reward function, exploration policy, or constraint must be version controlled for traceability. Safe exploration. We test new policies in shadow mode before exposing them to real users or assets. Reward monitoring. We continuously validate that learned behaviors align with business goals and don't exploit loopholes. Meta risk detection. This means watching for second order risk like reward hacking or unexpected emergent behavior. In short, we treat the learning process itself as something we must observe, govern, and roll back if needed. So now I'll get into federated learning. So federated learning, privacy preserving collaboration. Now let's move on to federated learning, which is becoming essential for industries where data can't leave its original boundary. Think bank, think banking, telecom, healthcare, e-commerce, whatnot. Federated learning lets each organization train models locally on sensitive data while only sharing encrypted updates. Using secure aggregation, we combine the updates into a global model without ever exposing the raw data. This is the most important. The result is a system that learns collectively, benefits from diversity, and stays compliant with privacy laws. Move on to production pipelines for federated learning. To run federated learning in production, we need a DevOps grade pipelines with four: model versioning, secure aggregation, drift detection, performance validation. I'll get into deeper into each category. What is model versioning? So every model update is cryptographically verified and traceable. Secure aggregation using homomorphic encryption or secure multi-party computation. Drift detection. So drift detection to identify when local models start to diverge, as I discussed in previous slides, or when malicious updates are introduced. Performance validation is very important, ensuring the global model performs fairly and consistently across participants. This ensures that the federated system is not just private, it's also auditable, stable, reproducible. Next one. Now, the third pillar and also most important component is explainable AI or simply XAI. As AI influences high stakes decisions, we need to answer why a model made a decision, not just what it decided. Explainability serves three key needs: regulators, engineers, stakeholders, and customers. Regulators who require transparency and audit. Engineers, we are engineers who need rapid debugging tools. Stakeholders and customers, most are important people who expect fairness and accountability. With explainability built in, we accelerated trust and troubleshooting at the same time. Now, we'll talk about embedding explainable AI in CI/CD pipelines. So, how do we operationalize explainability in DevOps pipelines? Three things that we need to make sure: pre-deployment checks, runtime explanations, explanation monitoring. Pre-deployment checks. It ensures each new model version maintains stable, reliable feature attributions. Runtime explanations. This generates justifications for every live prediction stored for audit and debugging. Explanation monitoring tracks the consistency of explanations over time. If feature importance suddenly shifts, that's an early warning sign of drift or data issues. This is very important monitoring part. In essence, we treat interpretability as a first class citizen in the CI/CD process. So now we talked about reinforcement, federated, and explainable. Now get into the governance, which is important. Governance and observability are where DevOps principles shine. Using policy as code, we can embed compliance rules directly into deployment pipelines, things like model approval, workflows, or explainability thresholds. Drift dashboards. Let us visualize distributions and prediction shifts with automated alerts and rollbacks. Progressive rollouts like canaries or A/B tests allow us to validate not only accuracy but also fairness and interpretability before full release. These three practices keeps AI releases both agile and compliant. So let's talk about reproducible training and model lineage. What I mean by that? So reproducibility is the foundation of trustworthy AI. Every dataset, hyperparameter, and code dependency must be version controlled. This is very important. Training environments should be containerized and deterministic so we can recreate any model on demand. With end-to-end lineage, we can trace every model from data injection to deployment, linking experiments, configurations, and infrastructures. This is what makes audits and root cause investigations actually feasible in complex AI systems. So next, This is very important topic I want to talk about. The reason is monitoring meta risk in production. A lot of people will neglect this one, but I would highly emphasize on this. Even with all that, AI systems can still face hidden risk. Three big ones to monitor: reward hacking, data poisoning, explanation drift. What is reward hacking? Where RL agents find loopholes that technically satisfy their goals but break business logic. Data poisoning, where federated nodes contribute updates. Explanation drift, where interpretability pattern shift, a subtle but powerful indicator of data or model problems. By tracking this meta risk, we move from reactive firefighting to proactive assurance. As I mentioned, this is very important. So next one, okay, practical blueprint. Okay, a lot of people now understood what is federated learning, explainable AI, and reinforcement learning. But now, where to start? If you're wondering where to start, here's a practical blueprint. Start with pipelines. Build CI/CD with versioning and reproducibility first. Layering governance. Integrate fairness, drift, and explainability checks into your gates. Monitor proactively. As I mentioned, I give high importance to this. Include meta risk metrics that was discussed in previous slides, not just performance. Release with confidence. Progressive rollouts let you ship safely and quickly. This stepwise approach lets DevOps team bring AI online without compromising trust. Closing. Unlock the power of intelligent automation. To wrap up, the AI trust thread isn't just a framework, it's a mindset. It helps DevOps team balance innovation with assurance, shipping reinforcement learning, federated learning, and explainable AI systems confidently, compliantly, and at scale. Thank you all for listening. I would love to connect afterward and hear how you are thinking about AI safety in your DevOps pipelines. And I also love to hear from your experience. What practices are you like using in in DevOps? Thank you once again. With that, I would like to sign off. Thank you.